Happy Thursday, students. Sorry I can't be in there with you today, but I am downstairs in my meeting, so I thought I would put together a lesson for you. It's going to be a little different today than it has been in the past. Hopefully you're able to get on the Chromebooks and get to this video. So a couple things you're going to need for today are your Module 10 note packets, which hopefully got passed out to you this morning. So you can open up to Module 10.1, the first section. And you're also going to need a calculator. Graphing calculator would be great, otherwise any other scientific calculator that has the 3 trig buttons, sine, cosine, and tangent, that will work too. So before we go ahead and get started with the notes, we want to make sure that our calculators are set in degrees. Since we're working with trigonometry and trig functions, it's really important that we make sure our calculator is set in that mode. So if you're working with one of our graphing calculators, you can check to see what mode you're in by pushing the mode button. And it's in the top row here. And when you push that button, a menu should open up. And you can check that menu about 3 options down. You should have the option between radians and degrees. So you can see my calculator is currently set in radians. I want to highlight down and over and push enter to get the degrees highlighted. And now you're in degrees. To close out of that window, just push clear. If you're using a regular scientific calculator or your phone, you're going to want to make sure that somewhere on the screen it says degrees or DEG. That means that you're in degrees. If you're not in degrees, you're going to get totally different answers and those will be incorrect. Okay? Now, what I would like you to do is make sure that you are taking notes as we go through the examples, and then when we get to the U-tries, the video will pause for a second and you will have to work those out on your paper and then put the answers in to the video. So make sure that you are following along. Okay. So let's go ahead and get started. Today we are talking about basic right triangle trigonometry. This is the kind of trigonometry that you learned about last year in your geometry classes. The only thing that's different this year is that we are going to start using theta, that's this Greek symbol here, to signify an unknown angle. So last year you probably put x in there, but when we're talking about an angle, we're going to use theta, and we'll use x to talk about an unknown side. Okay. You also, a couple other things we're going to want to remember from last year, even though this isn't trigonometry, we're going to use this a lot when we're working with the right triangles. Need to remember Pythagorean's theorem. And remember, Pythagorean's theorem is a squared plus b squared equals c squared. Where a and b are the legs and c is the hypotenuse. Okay. And then that last thing that you're going to need to remember from last year is that little acronym that you learned to remember sine, cosine, and tangent, and that was SOHCAHTOA. And that was to help you remember the 3 basic trigonometric functions. So here we have sine, which stands for opposite over hypotenuse, cosine, which stands for adjacent over hypotenuse, and tangent, which stands for opposite over adjacent. With this year, we're also going to add on 3 more functions, and those functions are actually the reciprocals of sine, cosine, and tangent. So the reciprocal of sine is called cosecant and is abbreviated CSC. And if sine is opposite over hypotenuse, then the reciprocal of that is hypotenuse over opposite. Secant is the reciprocal of cosine, and if cosine is adjacent over hypotenuse, then secant is hypotenuse over adjacent. And then last but not least, we have cotangent. It is the reciprocal of tangent. And if tangent's opposite over adjacent, then cotangent is adjacent over opposite. So then you can see down here below that cosecant is 1 over sine. That's the reciprocal of sine. Secant is 1 over cosine, the reciprocal of cosine. And cotangent is the reciprocal of tangent, 1 over tangent. So those are the 6 that we are going to be using today. So let's jump right to our first example here. It says, evaluate the 6 trigonometric functions of the angle theta. Well, in order to do sine, cosine, and tangent, we need all three sides of the triangle. And right now we only have two sides of the triangle. So we need to get that third side. And in order to get that third side, we're going to use Pythagorean's theorem, because you use Pythagorean's theorem when you know two sides of a triangle and you need to solve for the last side. So I'm going to start by doing that. A squared plus b squared equals c squared, where a and b are the legs, 5 and 12. So we get 25 plus 144 equals c squared. Add those together and you get 169. And then take the square root. So c is 13. And that will now allow us to write the ratios of the 6 trig functions. So I'm going to jot down again that acronym that's going to help me remember them. So, TOA. And I'm going to start with sine, cosine, and tangent. So I need sine of theta, and since sine is opposite over hypotenuse, I'm going to look at theta. The opposite side is 12, and the hypotenuse is 13. So that's my sine ratio. Then I need cosine. Cosine stands for adjacent, which is 5 over the hypotenuse 13. And then the last one for the regular 3R is tangent. So tangent of theta is opposite 12 over adjacent 5. Okay, so that takes care of the first three. Now we need the three reciprocals. So the reciprocal of sine is cosecant of theta. And since sine is opposite over hypotenuse, cosecant is hypotenuse 13 over opposite 12. Secant is the reciprocal of cosine, and that will stand for hypotenuse 13 over adjacent 5. And cotangent of theta is the reciprocal of tangent. So cotangent is adjacent 5 over opposite 12. And there you have your 6 trigonometric functions. Okay. Let's take a look at example 2. It says if theta is an acute angle of a right triangle and sine of theta is 4 over 7, what is tangent of theta? So I'm going to start by sketching a picture here of a right triangle and labeling one of the acute angles theta. It tells me in the problem that sine of theta is 4 over 7. Well, sine stands for opposite, so that must be 4, over hypotenuse, so that must be 7. Well, the first thing I want to do before I calculate the tangent of theta is find the length of the missing side. And again, I'm going to use Pythagorean's theorem to help me do that. So a squared plus b squared equals c squared. Solving for a leg this time, so a squared plus 4 squared equals 7 squared. I get 16 equals 49. Subtract 16. Get a squared is 33. Take the square root of both sides. And you get a is, since 33 is not a perfect square, I'm going to leave it as the square root of 33. Now, I can use that information to go and calculate tangent of theta. Well, tangent is opposite over adjacent. So the tangent of theta is going to be 4 over adjacent, which is square root of 33. Now, unfortunately, we have this rule, kind of like the rule that says the denominator of a fraction can never be 0. There's this rule that says the denominator of a fraction cannot be irrational. So that means we can't have a square root down there. So in order to get rid of that square root, we multiply it by itself. But what I do to the denominator, I must do to the numerator. And what happens when you do this is you get the tangent of theta equals, you multiply straight across, you get 4 times the square root of 33. But in the bottom, when you multiply a square root by itself, that's kind of like the same thing as squaring it. When you square a square root, they cancel out, so you just get 33. So our answer on this problem was B. Good. Let's take a look at example 3. Example 3 says find the indicated side length. So we're given two pieces of information here. We're not going to be able to use Pythagorean's theorem because we don't know both of the other legs. We only know one. But since we're given an angle, we can use trigonometry. So what I recommend is circle the angle and identify what two sides you have. We're looking for the adjacent side, and we know the hypotenuse. And this is going to help you determine which trig function to use. So if we look at SOHCAHTOA, and we have adjacent and hypotenuse, that means we're going to be using cosine. So I'm going to set up an equation. Cosine followed by the angle 30 equals adjacent, which is x, over hypotenuse 8. And to solve this now, I'm going to make this a proportion. And to solve a proportion, you cross multiply. 1 times x is x equals 8 times the cosine of 30. So this is where we're going to have to go to our calculator. And we should still be in degrees. And we're going to do 8 times the cosine of 30. And I'm going to close my parenthesis. And I get about 6.9. We're going to round to the nearest tenths place here. So x is about 6.9. And there we have found the missing side. Okay. Let's take a look at this example. It says again to find the indicated side length. So I'm going to start by circling my angle and labeling the two sides. I have 14, that's the adjacent side. I'm looking for x, that's the hypotenuse. So again, if I'm using SOHCAHTOA, knowing that I have the adjacent hypotenuse, I'm going to use cosine again. So I'm going to set up another equation here. The cosine of 51 equals adjacent 14 over hypotenuse x. And again, I'm going to make it a proportion and cross multiply, but this one's a little different this time. When you cross multiply, you get 1 times 14, which is 14, equals x times the cosine of 51. Now we're not done here because x is not isolated. In order to get the x by itself, you have to divide off the cosine of 51 on both sides. So in this example, to get x, we need to do 14 divided by the cosine of 51. So let's go ahead and do that. 14 divided by cosine of 51. Close my parenthesis. And I get that x is about 22.2. Good. Okay, at this point, I would like you to take some time right now to do these 3 questions. Make sure you work them out on your paper, and then you're going to answer them in the computer. All right, hopefully you've had a chance to work those out and answer those. So let's take a look at how you did. The first example says, evaluate the 6 trig functions for theta. And in order to do that, again, we're going to have to start by finding that last side. So I'm going to use Pythagorean's theorem. A squared plus b squared equals c squared. And I'm solving for a, the leg, plus 15 squared equals 17 squared. This is 225. This is 289. Subtract the 225 and you get a squared is 64. Square root both, and you get a is 8. So that's our missing side. So now we can go ahead and write the 6 ratios. So I'm going to start with cosine of theta, or sine, equals, I'm going to, off to the side, I'm going to write isoka toa. So opposite is 15 over hypotenuse 17. Cosine of theta is adjacent, 8 over hypotenuse 17. And tangent of theta is opposite 15 over adjacent 8. And then my 3 reciprocal functions. Cosecant is going to be a hypotenuse over opposite. Secant of theta is going to be hypotenuse over adjacent. And cotangent of theta is going to be adjacent, 8 over opposite, 15. And those are your 6 trig functions. Okay. In example 2, I'm going to sketch a picture. It says in a right triangle, theta is an acute angle, and the cosine is adjacent over hypotenuse. So adjacent is 7 over hypotenuse 10. So again, I'm going to start by finding that last side before I go and find the sine. And to do that, I'm going to use the Pythagorean theorem. Subtract 49 and you get b squared is 51. Since 51 is not a perfect square, I'm going to leave it as the square root of 51. And now I can answer the question, sine of theta, sine is opposite square root of 51 over hypotenuse, 10. And since the irrational is not in the denominator, we don't have to do anything else. That is the sine of theta, square root of 51 over 10. In our last example, number 3, we have 2 to do. I'm going to circle 40. 15 is the adjacent side. X is the opposite side. So I'm going to use tangent, opposite and adjacent. So tangent of 40 equals opposite x over adjacent 15. Cross multiply, 1 times x is x, equals 15 times the tangent of 40. And when you go ahead and put that into your calculator, you should get 12.6. So x here is 12.6. In our next example, I circle 55. 17 is opposite. X is adjacent. So again, we're going to use tangent of 55 equals opposite over adjacent. And let's cross multiply. 1 times 17 is 17. X times the tangent of 55. And now to get that x alone, we have to divide off the tangent of 55. And when you do that, 17 divided by the tangent of 55, you get x to be 11.9. So hopefully you were able to get all 3 of those correct. Here's our next example. It asks us to solve triangle ABC, and it doesn't give us anything specific that we have to solve for. So what we're going to have to do is solve means find all 6 pieces of information. 3 angles, 3 sides, and they're going to give you 3 pieces of information to start. So I put together this little box here to help you organize your answers. One thing that you should know is that capital A, B, and C are always the angles, and then small letter A, B, and C are the sides across from the corresponding angle. So for example, if we have angle A here, side little a is directly across from it. Here we have angle B, side little b is across from it. And here we have angle C, and side little c is directly across from it. So in the box, I'm going to put the first three pieces of information that the diagram already gives us. The little red square in the corner tells me that angle C is a 90-degree angle. I also know that A is a 28-degree angle, and I know that side B is 15. So that leaves me with one angle and two sides to solve for. I'm going to start with the angle. The third angle is the easiest because you know that all three angles in a triangle should add up to 180 degrees. So that means the measure of angle B must be 180 degrees minus the 90 and the 28 that we already know. And when I do that, that gives me angle B, the measure of angle B, to be 62 degrees. So I'm going to go ahead and put that in the box. To get the next piece of information, we're going to have to use trigonometry. Now we could use that 62-degree angle we just found, but I always recommend using the given information in case you made a mistake on solving for that other angle. So I'm going to use 28. I'm going to start by solving for side little a, and that's the opposite side. And I have side little b, which is the adjacent side. So looking at SOHCAHTOA, opposite and adjacent means I'm going to have to use tangent to solve for side A. So the tangent of the 28-degree angle equals the opposite, A, over adjacent 15. So set up a proportion and cross multiply. 1 times A is A equals 15 times the tangent of 28. And if I go to my calculator, I get 15 times the tangent of 28 to be, if I round this to the nearest tenths, that 0.9 is going to round up to 8.0. So A is 8.0. So now at this point, to solve for the last side, you could use Pythagorean's theorem. But again, I highly recommend not using the new information you've calculated, just in case you made a mistake on that. So I'm going to go back to the original information. I'm going to use 28 degrees again. I'm going to use the 15, which is the adjacent side, and I'm solving for C, which is the hypotenuse. So now, to solve for side C, adjacent hypotenuse means I'm going to use the cosine of 28 equals the adjacent 15 over the hypotenuse. Instead of using x, I'm going to actually use C, since that's the side's name. And I'm going to cross multiply. 1 times 15 is 15 equals C times the cosine 28. So to solve for C, I need to divide by the cosine of 28. So C equals, and I'm going to go to my calculator, 15 divided by the cosine of 28. And we get about, if we round that up to the nearest tenth, 17.0. So now, looking at our box, we have all 6 pieces of information, 6 sides and 6 angles, meaning that this triangle has been fully solved. Okay? Let's try another one. I'm going to go a little quicker through this one, so make sure you're keeping up with the notes. Pause if you need to. First piece of information I know, angle C is 90 degrees. Then the problem tells me angle A is 32 degrees. And side B is 10. So exact same information they gave us in the last problem. I'm going to start by solving for the measure of angle B, because I know 180 is the whole triangle, minus the 90, minus the 32. So that means that the measure of angle B is 58 degrees. Okay. I also know the side little b is 10, so I'm going to get that in the table. And now I'm going to start to solve for the other sides, A and C. So I'm going to use the 32-degree angle they gave me. Side A is the opposite, and I have B, the adjacent. So, toa. Opposite and adjacent means I'm using tangent of 32 equals opposite A over adjacent 10. Cross multiply, 1 times A is A, equals 10 times the tangent of 32. So I'm going to go to my calculator. 10 times the tangent of 32 is about 6.2. Okay? And now that leaves me with side little c. So again, I'm going to go back to the original information, the 32. 10 is the adjacent side. C is the hypotenuse. So adjacent and hypotenuse means I'm using cosine. So the cosine of 32 equals adjacent 10 over hypotenuse C. 1 times 10 is 10 equals C times the cosine of 32 divided by the cosine of 32. 10 divided by the cosine of 32. 10 divided by cosine of 32 gives me C to be 11.8. And now that triangle has been solved. Okay. So what I would like you to do now is I would like you to take a couple minutes and work through solving this triangle. And then go ahead and make sure that you put your answers in the computer, and then we will go through to make sure you have all your answers correct on this one. All right. Hopefully you were able to get your answers in there. Let's go ahead and see if you were correct. So I'm going to start by labeling the information I know. Angle 1 is 71 degrees, and side C this time is 20. And of course I know that angle C is 90 degrees. So to solve for angle B, I've got 180 minus 90 degrees minus 71. And that makes angle B 19 degrees. To solve for side A using my 71-degree angle, that's the opposite side, and I have C, the hypotenuse. Opposite and hypotenuse means I'm using sine. So the sine of angle 71 is opposite A over hypotenuse 20. Cross multiply, 1 times A is A, equals 20 times the sine of 71. And when you go ahead and do that, 20 times the sine of 71, you should get A to be 18.9. Okay, going back to the original information, 71 degrees. To solve for B, it's the adjacent side, and we have 20 hypotenuse. So adjacent and hypotenuse is going to be cosine 71 goes to the adjacent B over the hypotenuse 20. Cross multiply, 1 times B is B, equals 20 times the cosine of 71. When I put that in my calculator, 20 times the cosine of 71 I get B to be 6.5. So I'm going to go ahead and get that in the table. All right, sorry about that. Mr. Krieger interrupted me. All right, hopefully you were able to get all 6 of those in there, 3 angles and 3 sides. The last thing we're going to take a look at today are angles of elevation and angles of depression. Hopefully you remember this from geometry because this is a pretty big concept that was covered last year. But the important part about both angles of elevation and depression are that they start from a horizontal sight line. So for angles of elevation, you start from a horizontal sight line and look up. So that's an angle of elevation, like right here. For an angle of depression, you start from a horizontal sight line and look down. So this right here is an angle of depression, and they both form right angles. All right, so now that you know what angles of elevation and depression are, let's take a look at an example. This one says a parasailer is attached to a boat with a rope 300 feet long. The angle of elevation from the boat to the parasailer is 48 degrees. So if we sketch an angle of elevation increases. So since that angle of elevation is 48 degrees, we're going to put that right there. It says the rope connecting the parasailer and the boat is 300 feet, so that goes here. And we're solving for the height above the boat. So if we circle the angle we know, x is the opposite side, 300 is the hypotenuse. That means we're going to use sine. So the sine of 48 degrees is opposite over hypotenuse, which is 300. Cross multiply, 1 times x is x. And we get 300 times the sine of 48. So if I go to my calculator, 300 times the sine of 48, you should get that x is 222.9 feet. Okay? Let's try another one. This one says a deep sea fishing boat spots a giant octopus on the bottom of the ocean floor. The sonar detects that the octopus is at a depth of 5,600 meters, and this time we're looking at an angle of depression. So this is our boat. This is our octopus down here. Angle of depression goes from a horizontal sight line. Angle of depression is 56 degrees. Says that we're at a depth of 5,600 meters. And we're solving for the diagonal distance from the boat to the octopus. That's the hypotenuse. This is across from the 90-degree angle. And 5,600 is opposite. So that means we're using sine. So the sine of 56 equals the opposite over the hypotenuse. Cross multiply. 1 times 5,600 is 5,600 equals x times the sine of 56 divided by the sine of 56. And we'll go to the calculator, 5,600 divided by the sine of 56. And you get 6754.8. So 6,754.8 feet. Okay? Now, you guys take a second to try this one. All right, let's take a look to see if we did this one correctly. We've got a group of bird watchers looking up to some birds at the top of a tree. It says their angle of elevation is 37 degrees, and they are 75 feet from the base of the tree. What is the height? So for 37, this is the opposite side. This is the adjacent side. And that means that we're using tangent. So the tangent of 37 is opposite over adjacent, cross multiply, we get 75 times the tangent of 37. And when you calculate that, you should get 56.5 feet. Hopefully you were able to get that one correct. Okay. At this point, we're at the end of the notes. What you're going to do now is take a short break, and when you come back from your break, you are going to get your assignment, practice 10.1. This is a required assignment that is due when you walk in the door Monday. Because we're a little bit crammed on this unit, not only are we going to have required assignments, but we're also going to do the skills checks. So please make sure you finish practice point 1, 10.1 for Monday, and are prepared for a skills check on that. Okay? Have a great rest of your day, guys.